Hi, hello everyone. In this video, we'll discuss more on PDA design and also we'll be discussing more complicated problems. That means you all know that what is polyandrum. So polyandrum is you can any string you can take. If I want to reverse that string also same. Both original and reversed string should be same, then only you can call that as a polyandrum. That's the meaning of polyandrum. Then how to design a PDA for polyandrum with the middle C? That means it is like this. Design a PDA for following contest P grammar. So in their exam they may give the grammar like this. You need to understand what is that, how to design a PDF for this grammar. So they may also ask like this: design a PDF for language is equal to XC XOR. That is, XOR means whatever the X has given the string, that reverse of the X, right? That is the meaning of XOR. So X could be A comma B. The string in L or odd length, right? So any string as given, the first part of is X and the C is indicating the center point of X and XCR. XOR. Let us see some of the example of string, what string you can generate it from this grammar. So the first ABA is a X point, X string, then C followed by XR. If I reverse that, the X will get ABA. So another example is like this. It may be any of the letter it can come. AAA followed by C. Again reverse that A triple A will be get a same. So take another example, BABC BAB, right? ABCBA, right? So like that many more combination you can consider and test it. So once you understand this, how to construct a PDA for this polyandrum, odd length polyandrum, right? So design a PDA for polyandrum with middle symbol C. The middle symbol, why middle symbol C is using it here? The machine will understand that. So once ABA has read it, that means C has comes, that means you are ready for the second part of the string, that means X reverse string. Okay, you will be scanning from left to right, then again you have to reverse it in the given string from right to left, right? Then you will be comparing that when C has come, then if you move one step to the right, that pointer is pointed to here, then this A, left side A and right side A of the C, you should compare it. Similarly, left side of the B and right side of the B have to compare. That is a color coded here. There is color coded, right? Again, this last leftmost A of the C and rightmost A of the C, you have to compare it, right? Both the string are same. Whenever reverse that same string, it will be get the same combination, right? So every letter you have to compare it. Otherwise, suppose here it is A, here it will be B is there, then it is not a polyandrum. Okay, let us understand that how logic is works. Okay, so before using this animation, I'll tell you this: ABA is a X. AB in other part of that ABA is XOR. So X I can keep on pushing onto the stack whenever that is the first letter, that is A, push onto the stack. Then again B has come. Again you have to push that B onto the stack. Then again there is a one more character is A, push onto the stack. Then when you meet the C, as soon as I have seen C, that means the first part of the information already onto the stack. If you go to the next, when C is after C, just you read that C and retain the status of stack remains same, then you compare the left of the C and right of the C, what is the characters are there. There in this case the A on the left and B another A is on the right, then you have to compare it. Let us do that, right? You have to pop it, okay? Whenever that you pop the left and right side of this. What is the top of the stack now? B. Again, what is the right side of the rightmost of the C is a B. Then again you have to pop it. Okay. So we have popped the other number or other characters. Okay. Next. So there are one symbol on top of the stack, that is A. What is there in the input buffer? A. Then you have to matching these two letter. Then you have to pop it. Right. Finally, everything is you compare it left and right hand side of the string. Then both are matching, and then given string is odd length polyandrome. Okay. So then once you understand this logic, let us move to next step, how to design in terms of transition diagram. In terms of transition diagram, by using the transition table like this, so as you have seen in the previous video, this combination. So let us move. First combination is, so state is always Q0, you have start with the Q0, input is A, then on top of the stack is Z0, then you are pushing A onto the stack. So that is our motto, right? Whatever that it comes in X, that always pushing onto the stack. Okay, like we'll see that in transition diagram. Then so there may be still you are at in Q0, the input may be B, right? Even your given string is maybe not be start with A, it can be start with B as well, right? B on top of the stack is Z0, then you can that also you have to push it onto the stack. Then maybe there is a Q0, another that is one more, and input is A and top of the stack is A, then push A onto the stack. Then so then another combination may be like this, Q0, top of the stack is B, input is B and top of the stack is A, then you have to push it, right? So then this 4 combination taken care of all the combination, either A can start or B can start, or any number of A's on the first part or any number of B's on the second part, it can keep all pushing onto the stack. So this is nothing but the A pushing part of it, right? So this combination. Next, then Q0, still you are at in the Q0 only. So next it is, so any combination it may come, right? Input is A, on top of the stack is B, then you have to push it, because we don't know what combination the given string has taken here. In other combination as well, right? So even Q0 and B on top of the stack is B, then you have to push it, right? So these two are over, right? Okay. So then we'll see another combination now. So all this, any combination it comes, right? It is taking all this combination in one state itself, right? This entire state will be pushing onto the stack whatever the input string is there, right? So this combination, this transition will be taken care of, right? So then that means you read all the input in X and we seen C character, that means it is you are read all the X string. Then you are reach at the middle point, that is C is indicate is a center point of the X and XOR. Okay, then you read that C. Okay, your input is C. Suppose why this combination has come, so there is no A and B as taken, only C would be there. right? There is no A and B will not be there. If input is only C, that is, even if we refresh that C itself we will get. On top of the stack is Z naught, then you reach to the Q naught. Okay, read that C, retain C and go to the retain the top of the stack Z naught and reach to the Q1. Okay, then another combination, right? Q naught, still you are at that. So this is for only in absence of A and B, only C is the input. So in other combination, suppose you consider the X as some combination. So C and top of the stack is A, right? Because all the input has been already pushed onto the stack. C is a input and top of the stack is A. Then you have to retain as it is, then reach to the next state. Then so Q naught is the Q, still you are in Q naught. C is a input. It may be the other input as well, right? Retain that B and go to the next state. Okay, so we are not changing any combination, just you reading a input and don't disturb the top of the stack. These two configuration remain same, right? Top of the stack is remain same, and just these three combination, just reading C and without disturbing the top of the stack, you are changing this. Now we are reached to the Q1, then you'll let us move to the comparing what is there on top of the stack, what is there in the input buffer, right? So now we are at Q1. So A is a input. So because suppose that already it is input is A, then top of the stack is also A, then you have to pop it, right? So that popping is happening. This configuration, whatever that A is on top of the stack, what is input is A, as long as this configuration is this content in both the input buffer and top of the stack, keep on popping it. Other combination as also will come. So Q1, then B, and top of the stack is B, then pop it, right? So that it taking care of all this, right? So what is the next one? Q1, then there is no more input in the input buffer and top of the stack is Z naught, then just you read that Z naught, move to the next state. So that means it is a initial final state, right? So this will gives the this diagram will be reading the polyandrome with the middle symbol C, that means odd length polyandrome. Okay, so I think if you understand this concept very well, you will be pause the video, you can listen it again and again, it is easy for you to understand. Then this will gives the more clear, concise information because of this animation, right? This problem also is very important for your exam point of view. Okay, so let us see that how to trace the string, whether it will works or not. I'll take some example. So resulting state is Q naught. I have taken the 100 input is A, B, C, B, A. A, B is the input. When I give after C, you are reverse that A, B into B, A. Okay, so previously there is in Q naught, stating in Q naught, and read that A pushing onto the stack, that A Z naught will be in the on top of the stack. Then what is the next input? B, right? Read that B, again you are pushing onto the stack, BA is on top of the stack. Okay, then C is just you read it without disturbing the top of the stack, then you retain the top of the stack as usual. Then what is the input in buffer? B. So B is the input and top of the stack is B, then you have to pop it, just you have to pop it, because every B have to comes, you have to pop it, right? So then what is the next input is A and top of the stack is A, pop it. So now input becomes null, that means empty, nothing is there, and top of the stack is Z naught, then reach to the final state. Okay, like this we can trace any more input, you taken it on your own choice and trace it and practice this program. So just for a curiosity, I'll give some of the input for you people. You try this at home, practice. Is there this element, this kind of input is accepting or not accepting? So then try. Is there any, if you have any doubt, please you have to write it in the description box. I'll clear it in the next video. Thank you. Then we'll see another example. Design a PDA for AI bj ck such that I comma j comma k greater than or equal to 1. There are two conditions in this you have to satisfy. So what is that condition? One case is j is equal to I, in other case is j is equal to k. That means, so number of b's should be equal to number of a, or other cases number of b should be equal to number of c. So there are two cases are there. We need to construct it. How to do that? Let us understand. First you have to construct it for j is equal to I. J is equal to I. That means, so number of a is equal to number of b. Okay. So as usual, you have to keep on pushing it when a comes. So a is the input, top of the stack is z0, pushing a onto the stack, right? So another case here. So there is, the first case is as usual, right? The second case also would be a, right? So there is, so when a comes in, still you are in Q1, a is the input and top of the stack is a, push a onto the stack. So remaining a is in the input, keep on pushing onto the stack. This transition is taken care, right? By that time, so a all a's are on top of the stack. That next is input is b. Next input is b. Okay, next input is b. By that time, so b is a input. The top of the stack is a. Then pop it, right? Pop it. Okay, there may be one more b and top of the stack is a, so you can pop that as well, right? B is a input, top of the stack is a, pop it, right? So this is taken care by remaining a and b on top of the stack and input buffer respectively, right? So there is, so what is the next? It is a part of C is a part of the string, right? It has to be, C should have to read it and reach the final state when condition satisfy j is equal to I. So this up to this it taken care by number of a's followed by number of b, right? But C should be there, right? C also part of this string. Just you have to read that C, retain the top of the stack as a z0, reached the final state, right? Final state. Okay. So then, so there may be one more C also there, right? There may be only one C, reading that, retain as it is, reach to the Q3. There may be one more C in the input power, that also you have read it, right? Read that and all read them and retain the top of the stack is Z0, then reach to the final. So by this time, by this transition, read all the C in the input buffer. By retaining the top of the stack is Z0, then finally, so input becomes empty. Input becomes empty. Top of the stack is Z0. Read that and go to the next state as by reaching the final state. That means the first condition has been satisfied, that j is equal to I. Let us move to the other part of the, either this will be the I is equal to, j is equal to I. So that part is number of a is equal to b. In other cases, j is equal to k means b, number of b should be equal to number of c. Let us look at that. We will move on to the other part of the condition, j is equal to k. So by the time that we are reading, that means here is you are comparing B against to C, then you have to retain A as usual, just keeping part of that as a part of the string, then keep reading that A without disturbing top of the stack. Just read it, and by reach to the B, then keep on pushing B, then you have to, when reach to the C, keep on popping it B from the top of the stack, right? Look at that, you have to start now. Q naught is a input, Q naught is a state, then input is A, and top of the stack is Z naught. Keep on reading it. I am not pushing anything, that means you are unchanging operation applied here. So A is read, then top of the stack is Z naught, retain. We are not pushing any element out of the stack until read the B. Okay, again there may be another element, it may be come, there may be one more A would be there in the input buffer. Just read that, then retain same status in the top of the stack, go to the next state. That means you are in the same loop, right? Same loop. Okay, then by this time B would become, right? You are at Q naught, B is the input, then top of the stack is nothing is there under top of the stack because Z naught will be there, then keep on pushing it, then you have to push the B onto the stack, right? Next it is, again it may be there, maybe one more B should be there, then keep that also, you have to push it onto the stack, then push that onto the stack. That is this configuration or this transition. By the time you are in Q pi, then what would be the next transition, next move? There you are in Q pi, then all the BS on the top of the stack, then input is C and top of the stack is B, then you have to pop it, right? You are popping all this. Next, what is the next move? So still you are at the Q6, then input is C and top of the stack is B, pop it, right? Pop it, right? This transition taken care by remaining C and B comparison. So now look at that other combination. Next, Q6, the input become empty and top of the stack is Z naught, then go to the final state. So this will be go to the final state is a Q7, right? All other combination has taken care it, no more combination required to design it. This itself is enough to compare these two conditions, J is equal to I and J is equal to K. Look at this, this should be the J is equal to I. This part will be the J is equal to I, other part will be the J is equal to K, right? Or I is equal to J and J is equal to K. So we understood this concept. Let us move to the next problem. Is design a DPDA for language L is equal to A power n B power 2n such that A comma B is belong to sigma n is greater than equal to 0, right? That means it is n can be this. Based on this condition you have to design the transition diagram PDA. Okay, so A power n and B power 2n, that means every 1A there may be 2B will be there, right? So what is the logic? You have to use it to design the DPDA. Look at this, if n is equal to 1, then what is the given string? A is 1, B as 2, right? So how to design this? So there is so in earlier case we have seen only every 1A there may be 1B, 1C would be there, right? In this case, how to tackle this condition? There is like 1A is there, there may be 2B's are there, right? So how to design, how to tackle this problem in terms of designing a PDA? So try to understand that how to work out with this problem, right? So there is 1A as pushing onto the stack. So what is our condition is applied here? Sir, every 1A, one extra A are pushing onto the stack. So in earlier case there is 1A is there pushing 1A onto the stack. In this case every 1A, one extra A I am pushing onto the stack. Why? Because 1A against to 2B you have to compare, right? Because by that time 2A should be on top of the stack, there should be a input as a if at all input have two B's, right? Now it is easy, right? So 1A is one extra is pushing onto the stack. Okay, so when B comes here, popping it, right? Pop it, right? There is one more B is input buffer on top of the stack is A, so pop it, right? So now understood, right, concept that what is the logic in this case? Every 1A, one extra A pushing onto the stack, then you have to start comparing. Okay, now let us move to the design. So first move is Q0, input is empty, nothing is there. Retain, just read that input and retain the top of the stack Z0, then reach to the final state. Look at this. Okay, look at this Q0. So another case, so to Q0 and input is A and top of the stack is Z0, pushing one extra A onto the stack, one extra A onto the stack. So this will be transition. So here there is reading 1A, one extra is A is pushing onto the stack. So retain this transition for pushing one extra A into the stack, right? So second A, even that is also input is A and top of the stack is also A. So pushing one extra A onto the stack. So that is also same, right? This transition, right? What is that? Now by that time you are all A are pushing onto the stack, then B has come. So Q0, then input is B, then it is top of the stack is A, pop it, right? Pop it, right? What is the next move? So you are at Q1, again input is B and top of the stack is A, again pop it, right? That is the configuration. This will be the configuration. So what is the next? Right. So this is taken care by remaining A on top of the stack and input is there in the B, will be popping operation taken care by this. So what is that now? By the time all this happened, all this element is popped from the top of the stack, then input buffer become empty and top of the stack is Z0, then read that, reach without disturbing the top of the stack, reach to the final state. There is no more combination. I think this will work out. So this is a way you have to design. This problem also is very important. You can practice again and again. Okay, it's another way. One more trick I will give you. So in this we have every one extra you have to push it onto the stack. But in other condition also we can design it using other logic. Look at this, how that is possible, right? So just you have to look at this transition diagram. So there is, as usual, I will not push one extra onto the extra A onto the top of the stack. I will push only one A on top of the stack. So pushing it, here it is, another A comes, you have to push A, right? So here we are not pushing any extra A on top of the stack. When B comes, because that all the A is pushing onto the stack, first B comes here, B is a input on top of the stack A, then without changing the content of the top of the stack, either pushing A onto the stack or popping it, just you read the first B, reach to the Q1, right? Next combination. So here by that time you will be at the second B. The B is the input, top of the stack is A, popping it, right? Popping it. Again, this will pop it, okay? So there is goes up 1A. What is the next B? So again third B has come. So B is a input, top of the stack is A, don't pop it. Just you read that B without changing it top of the stack, reach to the Q1. Again fourth B comes here, pop it, right? Pop it. That means every alternative B you can pop it, right? Every alternative B you have to pop it, okay? So that's the logic. Without pushing extra A onto the stack, here every alternative B you have to pop it. Just here it is reading the first A, second B pop it, third B you have to just read it, the fourth A is you have to pop it. Like that you can comparing the number of A's and V's, okay? Finally, you reach to the final state. In other case as well, because n is greater than or equal to 0, input is become z naught, n is greater than or equal to 0. So that this will be the first. Without this, any of this can directly reach to the final state. It is input is empty, top of the stack is z naught, return z naught and reach to the final state. That also possible. So this is another way of constructing a language for a power n and b power 2n.